In this lecture, we are going to learn about a decorator pattern. Okay, so the thing that we are going to learn is about a decorator pattern. And how we will learn this is that we will take a coffee shop example. Okay, so we will take a coffee shop example, and what happens is they have a beverage. Okay, so they have asked a software person to build a class for their beverage, and they want that their class, what they should do is they should give a description in the menu, so what it's all about, so describe, and then it should calculate the cost of your beverage, okay, the coffee, whatever you have. Now the thing is, your drink has a few things, like you can have in your coffee soy. Okay, I might not pronounce these correctly, but let's say soy. Then you might have whip in your coffee. You can have mocha. Okay, you can have extra milk. Then, so these are the things that you can have. You can have them additionally in your beverage or your coffee, so that it makes them taste better and makes them according to your choice. Okay, so this is the case. Let's say these four things are there. Now your coffee, okay, the beverage is there, and there are, let's say, few different types. Let's say you have a dark roast. Okay, so I don't have much knowledge about coffees and such beverages, so dark roast is one. Then you have decaf. Okay, so this is another kind of beverage. Third one is espresso, so that is something I know. So espresso, that is there. You have now house blend. Okay, so these are some of your beverages. Okay, and in these, now let's say you can add these extra things. Okay, in these different beverages you can add soy, whip, mocha and milk. Okay, these are the things that you can add. So now what happens is that you are the software designer. Okay, so you are going to design classes for it where you have, so now let's try to see the problem first. If you know the problem, then only you can solve it. That's the basic thing. Okay, when you know the problem, you understand it better, then only you can solve it. So you are the designer. Okay, so you are the designer and you have come to solve this problem. So now the thing is, there are four extra things that you can add in your beverage, and there are four types of coffees. Okay, the dark roast, decaf, espresso, house blend. Now what happens is, in this dark roast, when you are preparing, so some pretty women can come and she can say that, okay, add soya, whip, mocha to my dark roast. Okay, so now these are the things that can be added, and let's say this costs 20 rupees, this one 30, this one 25, and this one costs you 10. Okay, so now this dark roast, the base class, this might have a cost of, let's say, 50 rupees. Now if you are asking me to add something to the coffee shop, that, okay, add soya and mocha, so the price will become 50 plus 20 plus 25. Okay, now some another person, he says that, okay, I want twice the mocha in my coffee, and let's say one whip and twice mocha. So your cost will be 50 plus 30 plus 2 into 25. So this will be the cost. So 80 plus 50, 130. So this way, now the thing is, you have to design the classes. So you can see one thing, you can say that, okay, I am expert in object oriented programming, so I'm very smart, and what I will do is I will make some classes. Okay, I will make classes like dark roast, but now you can see that dark roast also has so many combinations. Okay, so dark roast can be with dark roast with soya, dark roast with soya and whip, dark roast with soya, whip and milk, dark roast with soya, whip, mocha and milk, Not just that, dark roast with soya, whipped, double mocha and double milk. So many things are there. So now the thing is, if I'm going to derive so many classes, and for each one of them if I write, so let's say this is the base class, and for the cost, so for each of such ways, and even let's say I don't add any double triple, I can add these things. Okay, so dark roast, now any of these combinations are possible. So out of these four I can take 2, 1, 3 and so on. So I will have 4C1. So basically 2 to the power of 4 combinations for this one. So it is 16. Okay, so I can have soya and whip, I can have soya and mocha, I can have soya and milk, so on. Lot of combinations are there. So basically 2 to the power of 4 combinations are there. So for just one dark roast, now if I have just one option, either soya is present or it's not present, whip is present or not, so there will be a lot of combinations, and you will have to write 16 derived classes for this dark roast itself. So you will be writing dark roast soya plus whip, dark roast soya mocha, and so on, lot of combinations. So inheritance, even though it can help, but there will be a lot of code. Okay, so there will be a lot of 16 files for this derived class files. For decaf also you will have decaf with so many combination classes. So 16 here, espresso 16, so there will be 64 such classes. So 4 into 16, so 64 classes, subclasses will be there. So bombardment of classes. So this is not a very good solution. Then you talk with your friends, you think a little harder, you come up with next solution. Okay, so you come up with a new solution that, okay, why to have such things. In my beverage class, okay, I will have a base class beverage. In that itself, or let's say even in your, which was the dark roast, okay, that's a very fancy word, dark roast. So we have this class. In this itself I will have some boolean variables like bool, so b soy, then bool, we have mocha, okay, then we can have whip and milk. Okay, so these 4 boolean variables will be there, and I will have the cost function. Okay, so which will based on your presence of these values. Let's say again your soy is 20 rupees, this is 30, this is 40, this is 10. So it will be these booleans. So b soy into 20 plus b mocha into 30 plus 40 into b whip. Okay, so this way I can calculate the cost. Okay, and this is in fact much better method to solve the problem rather than the previous one of having 64 derived classes, or at least 16 for this dark roast. But you can calculate the cost like this. But one of the problem with this method is, let's say I'm adding something like one more thing, then you have to change the base method, and that's not a very good idea when you're playing with the base method. If something is getting added, everything should be loosely coupled in your object oriented good designs. Okay, so things should be loosely coupled, so that when I want to add something, I don't have to change it in the base class code. I need to just change it somewhere in some of the derived classes. So this is also better than the previous one, but not that smart. So here comes the decorator pattern that will help you. Okay, so in our decorator pattern we will see how for these kind of examples decorator pattern comes to our help. So in this lecture, so we just learnt about the problem where decorator pattern comes. So here in these kind of problems, inheritance just fails. You can use these kind of the boolean variables and so on for handling these combinations, but again this is not loosely coupled, so not a very good design idea. So in next class we will see about decorator pattern.